Okay, we're in the section on the polynomial multiplication. Certainly, we're going to talk through this. Some of this stuff may be horribly confusing to you, but I want to point out you've been doing multiplication for some time now, ever since grade school. The thing about the way you were taught this in grade school, you may not see the relationship between what you did in grade school and what you're doing in algebra, but really, it's really the fundamental idea behind arithmetic is going to extend nicely to algebra. All right. And so when you did multiplication in grade school, you were using what's called the distributive property of multiplication, right? I want to claim over here, though, again, we put little tiny videos over here for those students that benefit from those videos. Do not feel obligated to watch those videos unless they're benefiting you, right? We'll go through the examples. I'm sorry, we'll go through the lecture and then we'll go through examples. I am going to switch over to the whiteboard now. And give you 1 second to do so. And we'll talk through it. So, it says, certainly we've been dealing with the distributive property for some time now. And this is outlined for you right here. I'll go through that with you. And we're talking about the distributive property. And that's really the property that you used big time when you learn multiplication. I'm not saying simple times table, like if you did 7 times 7, but if you did like a bigger problem, like a problem like this over here in grade school, this would have definitely required the distributive property of multiplication. And I'll go through that with you. For a lot of students, though, they don't see the relationship, again, between what they did in grade school and algebra, but it's really the same process, all right? Now, granted, I'm not asking you to relearn what you learned in grade school. I'm asking you to see there's a relationship between the two, all right? Before we go forward, though, I want to point out that multiplication, this is A, distributed across an addition. We would say A distributed across to B plus C, AB plus AC, or the A distributed across subtraction, AB minus AC, all right? So we're going to extend this concept to this problem over here. And this is where a lot of students say, no, my teacher in grade school didn't do this. In fact, they did do this, all right? I want to point out what they were doing in grade school. And this might seem really strange to you, but in grade school, the teacher would have written down this, 553, 297. And what they would have done is taken this number 7 here and distribute across these 3 numbers over here. They would have actually done that. Well, you know what? You could think of it as this 7 here being distributed across these 3 numbers written this way. Then what did they do? They took the 9 and they distribute across these 3 numbers, one at a time too. It's a really complicated algorithm they gave you, but it does work, all right? Then last but not least, they would take the 2 and distribute across these 3 numbers over here. Now, granted, I'm not terribly interested in the number, but you realize when you're in grade school, they gave you problems like this, and you went through the work, and I got an answer like this over here. Let me just go through what it looked like as grade school arithmetic, all right? Write this down for you. 5, well, I'm going to black ink. 5, 5, 3, 297. Now, granted, it might look a little different, but 7 times 3 is 21. You'd carry the 2. 7 times 5 is 35. 35 plus 2 is 37. Whoops. 7 times 5 is 35, and 35 plus 3 is 38. Some teachers enforced a 0 there. You know what? I notice my penmanship is not too great. I'm going to just erase this, put the 7 down again. All right. 9. You know what? I'll erase these guys up here too, the carries. All right, I'm going to do the 9 now. It's actually not, it's 90. So 9 times 3 is 27. 9 times 5 is 45. 45 and 2 is 47. 9 times 5 is 45. And 45 plus 4 is 49. 0, 0. Get my eraser out again. Oops. Let's see. 2 times 3 is 6. 2 times 5 is 10. 2 times 5 is 10, 11. 1, 14, I carry a 1. 9, 16, 22. Let's see, 5, 14, 4, 5, 6. And then you would say, oh, I got an answer. Again, you may not have realized what you were doing, but you just did the distributive property multiplication. What you did this over here. Now, for a lot of students, this looks awful. But that's exactly what you did in grade school. All right. The only difference here is I'm not doing any of the carries. All right. No carries at all. All right. Let's get to polynomial though. All right. When I get to polynomial, what I'm talking about is I don't really like the numbers. And I'll be honest, I did not enjoy this arithmetic over here. Just didn't do it. I would much rather prefer you calculator to do that, but I get the answer. I know how to do it. Now, certainly we're going to talk about polynomial multiplication now, and I'm going to go through that with you. All right. So let's take a look at it. And I'm going to grab this guy over here and put him down here. And I'm just going to go through it. All right. And we'll talk about it one step at a time. Now, certainly when I draw something in here, that doesn't mean you have to do that. But what I'm going to claim over here is this 2x is being distributed across these 3 terms. And you're going to do it one at a time. Let's do the first one. 2x times 2x squared is 4x cubed. Okay. 2x times the next term is going to be minus 6x squared y. 2x times the last term is going to be plus 10x y squared. I want to give you a word of advice over here. I think variables should be written down in alphabetical order, like x, y. I think they should be. Someone's going to write them differently. You can. Order really doesn't matter for multiplication. Let's go to the next one. Someone said, what's the next one going to be? It's going to be plus 3y distributed across these 3 terms, one at a time. Let me see if I can do that. All right. So I'm going to shrink this down a little bit. And you know what? I'll just put it below it. What do you get over there? Let's see. You get 6x squared y. That's the first term, right? Because 3 times 2 is 6, x squared y. Again, I'm putting things in alphabetical order. Then what do you get? Minus 9xy squared. Then what do you get? Plus 15y cubed. What you're expected to do now is combine like terms, just like you did in grade school. If you remember the last problem we did, we had a bunch of numbers down. We had to combine them all together. Let's see what we get over here. 4x cubed. There are no x squared y. They just appear. And then I get 1xy squared. What am I doing? Combining the coefficients plus 15y cubed. Now, do mistakes happen? All the time. Go back to your key. Make sure you're looking at the answer in the key. What is that going to be? 4x cubed plus xy squared plus 15y cubed. Do mistakes happen? All the time. That's why we want to prevent that by looking at our answer key, see how we're doing. All right. Let's go to the next one. And let's see. This one's a little different, isn't it? It's not much different, but it's a little different. And I got to be honest with you, the variations on these is not great. I'm going to go through it, put it over here. We do have the key. We'll look at it later. And I'm going to go through it one step at a time. Whoops, let me go back to black ink. So what I want to claim over here, what I'm going to do here is I'm going to take this 3x and distribute it across these 3 terms. No, you don't have to put the arrows in. I'm just telling you what I'm doing. What's 3x times 9x squared? 27x cubed. 3x times 6x is plus 18x squared. 3x times 4 is plus 12x. That's done. Now what am I going to do? I'm actually going to take minus 2 and distribute across these 3 terms. And what would you get over there? Minus 18x squared. Let's see, minus 12x minus 8. Let's combine them together. So we get 27x cubed. Well, isn't that convenient? The x squares disappear because 18 minus 18 is nothing, and 12 minus 12 is nothing, and you get a measly 8, minus 8. All right, again, I can't say it's not. Look back at the key. Make sure you're staring at the same answer. All right. So I'm going to say, it's work. There's no doubt about it. We want to be able to do that work, though, and get good at it. Our goal, though, eventually is to look at this and write this down instead. You're never going to get there unless you can multiply. All right. We'll get there eventually. We'll go through a bunch of examples. All right. Thank you.